Good morning, students. Today we are going to start chapter number 3, that is atomic structure. In this chapter, you will learn about different atomic theories and about the fundamental particles of atoms, discoveries of the fundamental particles, different atomic models, atomic number, atomic masses, and isotopes. Now, first of all, what is atom? Atom is the tiny particle of an element. According to a scientist, atom is very small indivisible particle. Dayton's atomic theory. This theory was given by a British school teacher, John Dayton. He stated that elements are made up of small particles which cannot be destroyed and which cannot be divided, and these particles are known as atoms. Atoms of one element have same size, shape, chemical properties and mass. We know that one element has so many atoms in it, so all of the atoms will have same size, shape and mass. Atoms of one element are different from the atoms of other elements. For example, the atoms present in oxygen element will be different from the atoms present in carbon element. Compounds are formed when atoms of more than one type of elements combine. You can say that chemical substances are formed or chemical compounds are formed when different elements combine together in a simple whole number ratio. A chemical reaction is the rearrangement of atoms. But atoms are not changed themselves. Their arrangement will change in different chemical substances or chemical compounds during a chemical reaction. Atoms are neither created nor destroyed in a chemical reaction. Dayton's atomic theory was largely successful in explaining the laws of chemical combination, but there were some shortcomings in that theory. These are: number one, atoms of elements are indivisible. But modern theory says that each atom consists of subatomic particles that are electrons, protons, and neutrons. Number two, atoms of an element are identical in all aspects, but modern theory confirms that isotopes of an element have different masses. Now, what are isotopes? We are going to discuss in the modern atomic theory. What is modern atomic theory? Basically, as the time passed, new experimental facts led to the modification and extension of Dayton's atomic theory, and this modification becomes modern atomic theory. The important postulates of modern atomic theory are: elements is composed of tiny particles called atom. Atom of an element consists of subatomic particles called electrons, protons, and neutrons. Atoms of an element are identical in size, shape, and chemical properties, but they have different masses. Such atoms of an element are called isotopes. So we can say that isotopes are the atoms of an element having different masses. Compounds are formed when atoms of more than one type of elements combine in a ratio of simple whole number ratio, just as Dayton's atomic theory stated. And a chemical reaction is the rearrangement of atoms, but atoms are not changed themselves. It means that atoms are neither created nor destroyed in a chemical reaction. Atoms remain same, only they shift from one place to another place in order to produce new chemical compounds. Fundamental particles of an atom. The first hint about the subatomic particles came with the discovery of electron by M. Faraday, William Crookes, and J.J. Thomson. Electron is a fundamental particle of each atom having negative charge. The apparatus used for this type of experiment is called the discharge tube, which consists of a glass tube fitted with two metal electrodes connected to a high voltage source and a vacuum pump. Here in the diagram you can see discharge tube, which was used by J.J. Thomson in order to perform the experiment for the discovery of electron. Let us discuss the discharge tube experiment in detail. How the tube was constructed or the experiment was designed basically comes in the construction. This experiment consists of a glass tube of thick walls. The tube is fitted with two metal electrodes, and the metal electrodes were connected with the negative and positive terminals of high voltage battery. These plates are called cathode and anode respectively. The electrodes are basically known as cathode and anode. This large tube consists of a small outlet tube connected with the vacuum pump. How it works. This tube is filled with a gas at ordinary pressure. A vacuum pump evacuates the gas from the tube so that the pressure is reduced inside the tube. A high voltage is supplied through the electrodes. This high voltage is slowly increased till a change in the tube is observed between the two electrodes. Now what is going to happen between the two electrodes is streaks of bluish light moving from cathode, that is a negative electrode, to the anode, that is a positive electrode. It appears that these rays travel in straight lines from cathode to anode, and a glow, a shine is observed in the tube towards anode side where these rays strike. Like the rays coming from the cathode are striking on the anode and causing a glow. So, what was the result of the experiment? The experiment shows that these rays consisted of negatively charged particles. The rays coming from the cathode are negatively charged particles. The name electron was given to these units of negative charges. Electrons were obtained irrespective of the nature of cathode. Like whatever the cathode will be, or whatever gas you are using in a discharge tube, but electrons will be there and moving from negative to positive anode. This proves that electrons are constituents of all matter, because if you are using any cathode, electrons will be there. Now, what are the properties of cathode rays? The rays which basically are carrying the electron particles, they have properties that they cast shadows of objects placed in their path towards the anode. Like the rays are traveling from cathode to anode. These rays are known as cathode rays. They have electrons with them. So if we place any object in the way, they will cast shadows of that object. It means that they travel in straight lines. They cause a light paddle wheel to rotate, showing that they are material particles. These rays, although invisible, cause some material to glow or produce fluorescence. They are invisible, but when they strike at anode, as it has proven in the previous experiment, they cause the surface to shine or glow. They are deflected towards the positive plate in an electric field, showing that they are negatively charged particles. The E upon m ratio of cathode particle is 1.7588 is to power 10 coulombs per gram. And it is same for all the electrons regardless of any gas in the tube. Now what is E upon m ratio? We will discuss this in next chapters. They can produce, cathode rays can produce mechanical pressure, indicating that they have kinetic energy. About the discovery of other subatomic particles we will discuss in our next classes. Please don't forget to study from your textbook. Thank you very much.